Hello, welcome to Bare Metal Machine. My name is Jeff Audia, and I'm the developer of the Cartesian Display system. I'm going to give a brief overview of what this system is. The Cartesian Display is a computer system that works alongside an ordinary digital readout, or DRO. The system gives a graphical depiction of the part geometry that came from a CAD model, as well as a graphical depiction of the symbolic cutter moving with respect to that geometry in real-time response to your hand crank inputs. And it's meant to be used on an ordinary milling machine, such as a knee mill like this one. So at the risk of insulting a huge fraction of my audience, I have to do this for the sake of completeness. The term Cartesian simply comes from the name of the coordinate system that we all work in. Right? You have an x-axis and a y-axis, and if you have a point here at 4, 3, that's x equals 4, y equals 3. Those are Cartesian coordinates. Now, your DRO has been giving you Cartesian coordinates all along. We've been working in this system from day one. It's just that the Cartesian display gives you the same thing along with a graphical representation of what is actually happening. And by the way, it's not just a picture of the part. It's a mathematical model of the part that is derived from the CAD model. Okay, now the Cartesian display and the digital readout, these two systems are not aware of each other. They simply share the same scale signals. So when you set the origin of your workpiece, and you'll set 0, 0 here on your digital readout, at the same time you come down here and you set 0, 0 on the Cartesian display. So the XY reading here on your DRO is always going to match the XY reading down here. There's a little mini DRO down here in this corner. Okay, so they share the same origin, and that's the extent of the relationship between these two systems. Okay, so to illustrate how the system responds to you, this little circle here, that's the symbolic cutter, right? It happens to be a 1/2 inch ML, R equals 0.25. Okay, so I'm going to move the x-axis positive, and you see the cutter's moving to the right, and I go y-axis positive, cutter's going up. So it moves in real-time response to your hand crank inputs. And it leaves behind this little trail of cutter path so you can see where you've been, right? And that's obviously very handy. Right? So everywhere you move, the symbolic cutter moves with you. And you can always clear the cutter path too. And you can change the tool at any time. As I say, 1/4 inch end mill. Maybe now I'm going to be finishing these walls and these radiuses. Okay. Now you can also pan and zoom to any extent you like. For instance, I can zoom in. I can get the best tactical view of what it is that I'm doing, right? So if I'm machining into this corner, right, you could actually machine a part just by going by the lines. In fact, the nickname for this system is virtual scribe lines. And so you can zoom out, you can pan left, pan right. You can do whatever you need to do to give yourself the best tactical view of what you're machining. Okay? Okay, so the virtual scribe lines concept, it goes deeper than just being able to manipulate the tool with respect to the part geometry visually. So what we have is this radar mode. Radar, and I can go to mode normal. So what's happening is the radar is going to tell you the distance from the cutter to a given entity. All right. So if I hit the next or previous keys, this is going to index through the database of entities that are in the part model. So you see how it turned red? That's now it's telling me that that entity is on radar and the computer's paying attention to it. So it's giving me the distance d from the cutter edge to that line. So it's 0.146. If I move towards the line, the radar is going to go down to 0. If I move away, it's going to get bigger. Okay? That should suggest to you that if I drive the radar D down to 0, or very close to it, depending on how fussy you want to get. Okay? Now, I am exactly geometrically, mathematically on that line. So when I machine along it using the y-axis, okay, I am producing whatever dimension that line happens to represent without even knowing the dimension, right? All I care about is that d equals 0. Okay? So now if I'm machining along this surface, I need to know where to stop. So I need to put the next entity on radar. Okay? So I'm going to index to this next entity. Now that line is on radar because it's red. So now I know where to stop. So I just keep feeding in y positive until the radar gets to 0, or however close I want to get to it, okay? Let's say that's close enough, right? Then I can machine along this line. Now I need to know where to stop again. Next, next, right? And again, watch the radar, get it down close to 0. All right, let's say that was close enough. Now I can machine along this line, okay? So now you're using the radar to tell you the distance between the cutter and these part entities, and you're producing these dimensions without even knowing what the dimensions are. Well, I hope this brief presentation has been informative at describing the primary effect of the Cartesian display system, where you can model your part in CAD and then transfer that part model into the Cartesian display, where you can then manipulate the tool with respect to that part geometry to produce finished dimensions that you may not even be aware of. Now, there's several other videos that are much longer and more comprehensive that describe more details and more features. But this is the basics of it, and I hope you enjoyed it, and thank you for watching.